Hi everyone, my name is Mika Reinders and I'm going to be your online chemistry teacher for the year. A little bit about myself and my background. I've taught Cambridge chemistry for about 1.5 years now. I have a very big passion for chemistry and I'm currently doing my honours in chemistry. So I'm going to try my best to explain the best way I possibly can. So this year we're going to cover a lot of work. So you guys need to be ready for a lot of working hours during the week. Remember that everything does not always happen in the classroom, but it also happens when you go back home and you reflect on what we've done in the classroom. So welcome, and I can't wait to begin with you guys. Okay, so in front of me I've got a Hofmann voltameter. So these things are very efficient, especially if you want to do electrolysis even at your home. So all I did here was I took some copper sulfate salt that you can actually buy from a local pharmacy, and all you do is you just take some of that and you dissolve it in distilled water, and to save some time I just poured it in here. Remember to close your taps when you throw it in, and then it's going to go into your tubes. So what you then need to do is you need to make sure that you have a suitable power supply. Now this power supply is very effective because you can take it with you wherever you go. So your negative terminal is going to be connected to your negative electrode, which is your cathode. And so remember, in copper sulfate solution, your copper ions, which is your cations, is going to move towards the cathode. So what do we expect to form here? We expect to form copper, solid copper, to precipitate onto your electrode. Then if you follow your positive terminal all the way, you can see that it's attached to your positive electrode, which is your anode. So remember that anions move towards your anode. So in this case, remember that sulfates are never discharged, but instead your hydroxides are going to be discharged as oxygen gas. And that's why you can see all the little bubbles here forming, which is all oxygen that is trying to sort of escape through the tap. So if you let this run for, let's say, 2 more hours, you will see that the solution is going to start dropping more and more and more. And you will actually be able to measure the volume of the oxygen gas that you have collected at your anode. So to test whether this is oxygen gas, you can just take your test tube, you can collect the gas, you can take a glowing splint and place it inside your test tube, and if your glowing splint reignites or starts glowing even brighter, that's when you know you've got oxygen inside of your tube. So we can maybe do that test with the next experiment where we will be doing the same for dilute sulfuric acid. So what we're going to do now is we're going to remove the solution. So I'm going to disassemble this whole structure. I'm going to take out the electrode here, the cathode, and we're going to see if any copper has formed on the cathode. So remember to switch off your power supply when you disassemble the whole structure. It really is quite simple. So you can take off these clips. Okay, so now you've disassembled your voltameter. So make sure that your taps are open when you pour out your solution, otherwise you won't get very far. So also make sure that everything is inside, and then you can just pour it out. You can see this tap is a little bit struggling a bit, so just twist it around until it opens up. And just let everything drain out back into your beaker. And I can already see the copper on the electrode without even taking it out. So now we can just remove this electrode here Just make sure that you are very, very careful, because it can be tricky sometimes to remove this. Okay, I've got it out. So now I'm going to turn the electrode, and you will see a red-brown color on the electrode, and that is pure copper that has formed from your solution. So you can see that the copper ions reduced in solution to form solid copper. So that's pretty amazing. So I think if you let this run for a few more hours, you're probably going to cover this whole electrode with copper. Okay, so now it's time to connect your terminals to your electrodes. So I'm going to connect this terminal here, and I'm going to connect this terminal over here. So your positive terminal is connected to this electrode here. So remember, this is now going to be your anode. So your anions is going to go towards your anode. So that's going to be your sulfates and also your hydroxides. Remember that your sulfates will not be discharged, but hydroxide will be discharged in the form of oxygen. So we expect to see oxygen gas forming over here. For your positive terminal, for your negative terminal, which connects to your electrode over here, which is your cathode, your cations will go towards. Now the cations in this solution is only hydrogen ions. So the only gas that we can expect to form here is hydrogen gas. And after running it, you will see as soon as I switch this on, it's going to form gas immediately. So I'm going to let it run for a while, and then I'm going to quickly grab a few things to test for the gases. So let's switch on our power supply. Immediately you can see a lot of bubbles forming, and you will see the solution is going to start running down, and you can actually then measure the volume of your gas that is forming. So I'm just going to let it run for a while until we have enough gas to test. I'm also using platinum electrodes in this case, because remember, we don't have any metal that's going to precipitate onto your platinum. So it's safe enough to use platinum, and it's inert, so it's not going to react with your solution. So you can see your hydrogen gas is forming much quicker than your oxygen gas. So while we are waiting, I'm quickly going to go grab the Bunsen burner and the glowing splints, and also a box of matches, so that we can test for the two different gases. So give me one moment. So I brought my equipment, and for those of you who have practical experience, I'm sure you know how to light a Bunsen burner. So remember that it's very important to ensure that this little silver thing over here is pushed up all the way, so that you allow enough oxygen to come through your burner. You want a blue, bright flame. You don't want an orange, yellow flame, otherwise your heat is too low. So what I always do is I'm lighting my match first, and then I'm opening up my gas slowly. And there I have my Bunsen flame. Okay, so now we are ready to collect the hydrogen gas. You can see a lot has formed. So I'm going to open my tap, because remember it was closed. I'm going to put this test tube on top. I'm going to open my tap, and you will see the solution picking up. I'll close it up with a stopper. So inside here, I now have my hydrogen gas. So we are going to test whether this is hydrogen gas. So the test for hydrogen gas is to take a glowing splint, to put it inside, and it's going to make a loud pop sound. So let's see if that's true. Then I'm going to take my wooden splint, and I'm going to make sure that it has a nice flame to it. I'm going to put it inside here, and we're going to listen to a pop sound. Woo! Did you hear that? So you definitely have hydrogen gas. We are going to test for oxygen gas. So I'm going to open this tap quickly. I'll close it up. Okay, so now I have oxygen gas in here. I'm just going to switch this off for a moment, otherwise the solution tends to bubble over. Then I'm going to light my Bunsen burner again. Now remember, when you test for oxygen, it's supposed to relight a glowing splint. So make sure that you have a splint that you warm up to get a nice flame. And you sort of want the flame to go almost dead just before you put it inside of your test tube. So I'm going to put this off. It's going to go almost dead. And when I put it inside, it should relight. Did you see that? It relighted, it went brighter. So you definitely know that you have oxygen gas at this cathode forming. Okay guys, so that was that for this lesson. I hope you enjoyed the experiment, because I definitely did. And I'll see you next time when we're doing topic 8, which is on acids and bases, and then we'll work with a burette and a pipette and also an Erlenmeyer flask to do a titration. Hope to see you then. Have a good one. Bye.